Right, we'll go ahead and begin. Hope you guys all have been enjoying your time in Cisco Live. Hope you've been crushing your steps, and I know I have anyways. So, my name's Cameron Bowie. I'm a technical consulting engineer in the data center networking space. I've been supporting the Nexus platform for 5 years, anything from the 9K, 7K, 6K, 5K, 4K, it does exist, it's 3K, and then 2K, also known as the FEX. And so ultimately today I'd like to share some of my knowledge and experience in today's breakout session, monitoring and troubleshooting vPC and VXLAN EVPN in a data center environment. So after this session, there may be some questions regarding some of the material we covered today. Please feel free to reach out to me via the Cisco WebEx app if you have any questions regarding the material we covered today. Alternatively, throughout the remainder of Cisco Live, I'll be in the Technical Solutions Clinic where I'll be happy to take any questions. We can have a conversation offline there as well. So today's session, we'll be reviewing tools we can use to monitor and troubleshoot the vPC and VXLAN EVPN fabric. Additionally, we'll review the most commonly seen problems, VXLAN problems we see in TAC, and how we go about fixing those. So network engineers often find a lot of difficulty with troubleshooting VXLAN just because due to the large number of components involved. And so it can easily become a bit of a sticky situation when trying to determine how to proceed, So today's session, we're going to review some tools we can use to go and address these challenges. So our first tool for review is going to be our consistency checker. Let's assume we're in a scenario where we suspect that the VXLAN fabric may be contributing to some sort of packet loss that we're seeing, and we'd like to get kind of a head start on our investigation. Well, that's where our consistency checkers come in. So, like most network issues, the first thing we'd like to rule out is a possible misconfiguration. So here we see an example of the VXLAN configuration checker in action. And so the command show consistency checker VXLAN config check is going to cause the switch to review the VXLAN configuration and look for best practices and required configurations. Upon completion, it will then provide the network engineer its findings and point out whether we're missing some sort of required configuration or we're not following a best practice somewhere. Now, the thing that we have to keep in mind is this is only supported for some deployments. We are working on expanding some other deployments out there, but so right now, we do not support TRM with this consistency checker, as well as flood and learn and sorry, drew a blank, and downstream VNI deployments. Bit of a rare one to see, but it is out there. Apart from our configuration checker, we also have an infrastructure check. The infrastructure check is going to validate things such as our control plane, our VXLAN hardware and software programming, and then lastly, the multicast tables as well, for those that are running multicast for the BUM replication, or yeah, for your BUM traffic. But it also will validate the ingress replication as well. So our next tool for review is going to be the ICAM scale feature. This ultimately allows us to identify current and future problems from the perspective of scale. And so we can ultimately use this information to prevent oversubscribing a switch. So with ICAM data, we have 3 different triggers. We have an on-demand trigger, and that's going to be via show commands. A periodic trigger, which is going to be where we configure the switch to collect scale data based on an interval that we configure. And lastly, there's going to be a utilization-based trigger. And this is going to trigger a syslog whenever a certain utilization threshold is reached. So here we see an example of an on-demand trigger for ICAM scale data generation. And so this output, the command show ICAM scale VXLAN is ultimately going to provide us our current scale limitation for all the VXLAN features, and then also, as well as provide us the verified scale limitations. And these limitations are what's provided to us by our BU. And so ultimately, this allows us to determine how close or how far we are from a particular limitation. And so we can ultimately leverage this information to take proactive actions rather than reactive ones. Because it's much more fun to take action proactively rather than reactively and try to figure out or engineer a way out of reducing our scale on the fly. That's not fun. So additionally, ICAM is able to monitor some things outside of VXLAN. So it can monitor our FibTCAM and ACL-TCAM. However, for today's session, the main thing that I want to bring attention to is going to be the ICAM monitor scale command. That specifically is going to be what's going to enable our periodic logs for ICAM, as well as our utilization-based syslogs. So here we go into, on this slide, we're going to go into how we fine-tune our thresholds. So by default, we will generate a informational severity message at 80% utilization, a warning severity log message at 90% utilization, and a critical severity log message at 100% utilization. Now we can fine-tune those so that we can be to any value that we'd want, so that we can be informed a little bit earlier if we'd prefer 80%. Perhaps you'd like to be informed at 70%, so you could reduce that if you do so choose. And so now here we go into how we fine-tune our periodic scale logs. And so by default, we're going to collect a total of 168 entries total, and that's going to be done every 2 hours once we configure that ICAM monitor scale command. Now, we can increase that to 1,344, and we can also modify that interval to as low as 1 hour to as high as every 24 hours. Now, how we go about utilizing those entries, that finite number of entries, is totally up to you. With a more aggressive interval, we're going to have more data that covers a shorter period of time, which could lend itself more useful for investigating, it could be useful for investigating utilization after a particular event. However, on the flip side, with a less aggressive interval, we will have that same amount of data but covering a longer period of time. And so that could be useful for determining your utilization over a longer period of time. So there are situations where, there will be situations where the consistency checker and the ICAM data is not going to be enough to triage an issue. So what I'd like to share is some of the most common problems that we see in TAC and how we go about fixing them. So our first problem is going to be the IP forward command. Oftentimes, network engineers will initially deploy their fabric as purely L2 and decide to maybe look into deploying that L3 functionality later, and they'll use an external device to perform their routing between their subnets. But eventually, they may opt into deploying that L3 functionality onto the VTEPs themselves, but forget a required configuration on the L3 VNI, which is the IP forward command. So, and that's going to be that command would be applied on that VRF SVI or the VNI the SVI that corresponds to that L3 VNI. And so let's go ahead and take a look into that a little bit deeper. So in this example here, we're going to have our VNI 100.144, which is our L3 VNI for the VRF first tenant. So show NV VNI will give us that output. We see our VRF, we see our VNI. Now we see that same VN segment corresponding to VLAN 1444. And what we're seeing is that we're lacking that IP forward command under that interface. And then here we're going to go ahead and give some additional details regarding this particular scenario just so that it makes sense. So we're going to have VLAN 144 mapped to VNI 100.144 and VLAN 244 mapped to 100.244. And so ultimately this leaf is going to be acting as our gateway for both of those VLANs. And so we see the Anycast gateway, and then we see the IP. And so what we see here is that pings that are going to be within that same VLAN or VNI is successful. However, pings from between different VLANs is not successful. And so that's ultimately going to be our symptom when we have that IP forward command missing, is that inter-VLAN traffic is going to be busted. So in short, to fix this issue, we would need to implement the IP forward command on that VRF SVI. And the reason for that is because when we're sending traffic, VXLAN encapsulated traffic, when we're sending that VXLAN encapsulated traffic, but that routed traffic to another VTEP, we're going to be sending that over the L3 VNI. And so that L3 VNI, that VRF, that SVI that corresponds to it, normally is never going to have an IP address. So when that packet arrives on the remote VTEP, it's going to see that packet maps to that L3 or to that VRF SVI. And once that SVI receives it, it has no IP address, it'll drop the packet. So the IP forward command specifically tells the switch to perform an IP-based lookup in the event I receive a packet on this interface that doesn't have an IP. So it changes the behavior there so that we actually route that packet into the appropriate SVI. And so here, we go ahead and implement the IP forward command, and now that we see pings are working as expected. Our next most commonly seen problem is going to be underlay subinterfaces or subinterfaces used as uplinks to the fabric. Now, we most commonly see this with new deployments where the network engineer may not be familiar with some of the limitations that we have for what you can use as an uplink. And so uplink connectivity is generally seen as quite simple, but in the event that you use a subinterface, you may find yourself in a situation where things aren't going to work out quite right. So in short, the subinterfaces for uplinks have never been supported in VXLAN since day one. However, we do frequently see customers in the TAC using those subinterface, and the symptom is always going to be indiscriminate packet loss. It's very random. Now, the thing is in 935, and the reason why people will use subinterfaces is so that they can maintain some other classical Ethernet traffic that may not necessarily need to be VXLAN encapsulated. So in short, what we don't want is we don't want to use those subinterfaces for handling actual VXLAN encapsulated traffic, and then additionally. And then one thing I would want to mention is that you can use the parent interface for VXLAN encapsulated traffic and still keep all your classical Ethernet traffic on those sub-interfaces. So that would be a situation that you could do if you're on 935 and later. All right, our next most commonly seen problem is going to be ARP suppression without Anycast gateway. And we most typically see this present itself as a scenario where hosts are unable to resolve ARP. And most often, we see this issue where a network engineer may be deploying this feature with the intent of reducing the amount of ARP traffic that is forward over their fabric. However, there may be a misunderstanding that we could decouple Anycast gateway and ARP suppression. However, that is not the case. They are a one-piece solution. If you're going to have ARP suppression, you have to have Anycast gateway. And so in a scenario where we're missing that, we're going to go ahead and review what that would look like. So here we have a host attempting to ping within the same subnet. So we have host 172.16.144.1 attempting to ping 172.16.144.34. And so what we see here is ultimately the pings are timing out, and ultimately this is boiled, and so upon further investigation we determined that it's because ARP is ultimately not resolving between, for that particular host. So in this case, it's a bit unique because we're using another switch as our host. So I know that we're going to be communicating on VLAN 144. However, if we were in a scenario where we just had a normal host, then what we'd want to do is we'd want to get the MAC address for that host and then do show MAC address here to determine what VLAN that host is communicating on, because in the next steps, we're going to show how we go about investigating further for this particular scenario. So once we determine the VLAN for that particular host, we can then use show NVE VNI to determine what VNI that host maps to. And so the big thing that I'm seeing here, or that would raise a red flag for me, would be that the suppress ARP flag is currently active. So by seeing that, I immediately know that I need to look for the SVI corresponding to that L2 VNI, the Anycast gateway feature enabled under that SVI, as well as the global MAC address defined for Anycast gateway. So just to double check, we go ahead and run show run interface NVE, NVE1, or show run NV overlay. The command will result in the same, and so we see that suppress ARP is present. So right then and there, I know I need to be looking for the Anycast gateway feature on my SVI. And so what we see here is, upon further investigation, we look for the SVI corresponding to VLAN 144, and we see that it's not present. So that in and of itself tells me that there's an issue here, because if you don't have an SVI, then you're not going to have Anycast gateway configured for that particular VNI. So in short, ARP suppression is only supported in a scenario where we have Anycast gateway configured for the SVI corresponding to that L2 VNI. And so what that would ultimately look like is we'd see the global MAC address configured for the Anycast gateway, the virtual IP for the SVI corresponding to that L2 VNI with that shared IP that's going to be shared amongst all the leaf switches. And so now we're going to go ahead and observe what we need to do to basically fix this particular scenario. And so instead of deploying Anycast gateway in this scenario, we're going to go ahead and just remove the suppress ARP feature. Now, doing so is going to require bouncing the NVE interface, which is a disruptive action. So I don't want to lead anyone astray here. Doing this would disrupt any other VXLAN traffic. So I would only do this under the scenario where we have a maintenance window, or we just have the go-ahead for doing something that would be disruptive to our VXLAN fabric. So we go ahead and implement, or go ahead and add no suppress ARP to remove the ARP suppression feature on both the leaf switches. And then what we see here is that we're now able to ping, which is because we would then be able to resolve ARP in that scenario. So our next most commonly seen problem is going to be eBGP peering to a host. So there may be situations where you may want to build out an eBGP peering from a leaf switch to maybe a virtual router that's residing on another remote leaf switch. So what we see most often is that Anycast gateway is very widely adopted, and so as a result, we have this feature that makes all your leaf switches indistinguishable from another, and yet when you try to build out an eBGP peering with this shared IP that's shared amongst all these other leaf switches, we struggle to form eBGP neighborship because another switch may be consuming that packet because we're sharing that common IP. So ultimately, what we need to do to address that is we need to be able to distinguish ourselves from those other leaf switches. A bit of a fun analogy that I kind of came up with when thinking over this was imagine a neighborhood where all the mailboxes had the same address, which is effectively what NECAS gateway is. It's that shared, it's common egress point for all of our packets. But in this case, we're going to talk about mail. So you go ahead and send out your package. You could choose any one of those mailboxes, and your package will get sent out. But what if someone needs to send a packet specifically back to you, and you happen to be at the house, down the way, but the packet arrives at another house? Well, from the mailman's perspective, he did his job. So just like in the mailbox scenario, we need to be able to distinguish where we are, and so with the VTEP scenario is the same. We need a way to be able to distinguish ourselves when we are in a deployment using NECAS gateway. Oh, I jumped ahead. Sorry. Okay. So in order to distinguish ourselves, we need to go ahead and create a loopback in that tenant VRF where we're trying to form that neighborship, so that when we do source that BGP packet towards that remote host residing on that other leaf, that host has a new IP that it can use that distinguishes us from those other leaf switches. Okay, and so our last most commonly seen problem is going to be MTU. It is kind of a bit of a basic issue, but the thing is it is very common. We see it very, very often. And so it often presents itself as a packet loss scenario. And the reason for that is because our packets are going to naturally be inflated a bit with VXLAN deployments, just because of that additional 50-byte header. So ultimately, to correct that, we need to ultimately increase the MTU on all of our fabric-facing interfaces. And so that would be our go-to strategy for addressing that particular issue. Okay. And so lastly, that pretty much concludes our session. I really hope that the information I shared with you all will be helpful, and that exposure to some of these problems that we run into can ultimately, or that I've discussed today, will provide you the information needed to address these issues in the event that you were to run into them. But if anyone has any questions regarding any of the material that we covered today, I'm happy to take your questions. Any questions? Sure, go ahead.
So the EVPN membership with the leaf, if we have the host inside the server, the virtual environment, and if it is a VLAN type, can we use SPI with a unique IP to do instead of loopback?
So if you're going to be using an SVI, so that where that comes into play specifically is because NECAS gateway is going to that scenario only applies when you're using NECAS gateway, because you're going to have that shared IP amongst all your other leaves. So even though I don't have a drawing, so let's say we have a VTEP here, and we have and then we're going to have our spine here, and then another VTEP here, and then we have a remote host. If I need to send that BGP, if I'm trying to build that BGP neighborship from this left-hand side leaf to this remote host on this right-hand side leaf, where that shared IP becomes an issue is because when I send that packet with that shared IP, it'll make it to that host no problem. But when it comes to that responding to that packet, this guy also has that same IP. And so he will end up consuming that packet. And so by having that dedicated loopback in that tenant VRF, we distinguish ourselves apart from the shared IP that's common throughout all the other VTEPs. Does that make sense? Did I answer your question? Oh. Oh, okay. Now, if you're local, yeah, you don't have to worry about that at all, because at the end of, well, It would still be recommended to use a loopback in that scenario because, I mean, if that host were to ever do some sort of vMotion, you might want to, having that dedicated loopback is going to allow you to still maintain that neighborship in the event that it were to move anywhere. Any other questions? Sure. Actually, the configuration checker will actually catch that. So for the longest time, admittedly, I would actually troubleshoot. I would focus on just my old kind of habits of troubleshooting, doing a path of the packet type of analysis. But now more so, I find that if I hop on a call, the first thing I personally want to run now is that consistency checker or that configuration checker because it does catch quite a lot of things, and so it can be a bit of a time saver. So you could absolutely use that command to basically catch that IP forward issue. Any other questions? Oh. MTU checks are, I don't believe they are included, but I can get back to you on that. Any other questions? No? All right. Well, oh, sure, go ahead.
On the ICAM monitor metrics that you set, you mentioned that the alerts will come through a syslog message. Does it matter what level you send to your syslog that those messages will get forwarded as well?
Right. So, and just so that everyone else can hear or be aware of the question, was that will we need to modify our logging level for those syslog messages to be visible? Is that kind of okay? No. So I definitely made sure I tested that, and so basically with the default logging level, as long as you have that ICAM scale monitoring command configured, if you reach that certain utilization threshold, you will see that log message absolutely.
So it will accept regardless of what level you set to your syslog, whether it's informational, notification, or anything.
Correct. Yes.
Thank you.
Mm-hmm. Sure. Go ahead. For checking the control plane? Yeah, so the command, let's see, I believe it was, the infrastructure check is the, oh, here, no. Yes, yeah, the infrastructure check would ultimately be what would check your control plane. Is that where? Yes, hardware and software. Mm-hmm. Sure, go ahead. Multi-site. I'll have to get back to you on that. I'm fairly confident that it does, though, but I'll get back to you. Yeah. Sorry. Any other questions? No? Oh. All right. Well, I hope you all enjoy the rest of your time here in Cisco Live. And also, yeah, my invitation still stands. If you have any questions regarding the material that we covered today, I'll be in the Technical Solutions Clinic, and I'll be happy to discuss this further with all of you. All right. Thank you all.